Let us see. So, nah, we won't recap. We'll go straight in. Annie, do you already know how you would go about solving these? So before, what you were solving was cos theta equals something. Now you have cos 3 theta. Any idea what you do there?
Do you divide the other side by 3 to get
It's like it's in a bracket, so you can't do that yet.
Oh, no, I don't know.
The first thing you'd have to do is get rid of the cos. How do you do that?
I don't know.
You have forgotten. You do your arc cos to both sides. So that leaves you with 3 theta, and the other side is arc cos 0.766. That's the cos with the little -1. What is that? Do you have your calculator?
Mm-hmm.
You might be quicker than me.
I got 40.
So 40.0 or?
Yeah, 40.0.
Okay. Oh, 40. I'll leave it as 40. 3 theta is 40. What is next?
Now theta equals 40 divided by 3.
So theta is 40 over 3. And
Yeah.
they wanted all of the answers in the interval 0 to 360. Do you remember how we get additional answers?
Yeah, there's like the rules. So for cos sub from 360.
Yep. And so sub what from 360?
40 over 3.
Very close. This is why this is the harder trig. It's because of bidmas. So instead of 40 divided by 3 and then, instead of 360 minus 40 divided by 3, you have to do 360 minus 40 and then divide that by 3. And so what is...
So where do you put brackets then?
I'll give you the easy way in a second. I'll give you the easy way now. So instead, 360 minus 40 over 3. So that's the mistake everyone makes. It's actually 360 minus 40 and then like that divided by 3, something like that. That whole thing over 3 or that whole thing divided by 3.
Okay. I got 320 over 3.
That's it, 320 over 3. And let me just see the wrong answer. 360 minus 40 over 3 would be 1040 over 3. And so to make sense of this, I think they'll give me a picture, will they? Yay. Oh, they gave me a cast diagram. Boo. Part B gives me a better picture. It's basically a stretch. So if you had y equals some function of x and it became y equals f of 3x, what transformation has happened?
I can't remember what that is.
Young lady. Hang on, let me drag this down. it is being multiplied. So it's a number being multiplied. So it's a stretch.
Yeah.
And it
Okay.
is in the bracket next to the x. So it is in the x direction. And it's always the reverse, like when you bring it to the other side. And so it's divide by 3 or times a third. What that looks like on a graph. And so I'll give you the understanding first. So this is the cosine graph. Usually it looks like that. If it is stretched by a third, you now have three of those graphs in the same domain, I think you'd call it. And so what we did was when we find our first answer, let's say it's here, we got our answer, yay. But then our second answer, we thought it would be somewhere here, but it's actually like here, something like this. It's because the graph has been stretched. That's the explanation. I have cleared my conscience. I shall now give you the easy thing that makes it all very easy, that you can just use the method you're already familiar with and will always work for everything. The only difference between this and what we did before is instead of 1 theta, we have 3 theta. And so we do something like let 3 theta be equal to a. And so what does it become?
What do you mean?
So replace 3 theta with an a, with a. What does
cos A.
So cos a, everything else is the same. And then you would do arc cos. So a is 40. Second answer.
(360 minus 40).
Yep. Which is
320.
320. And so a is 40 and 320. And now we just kind of did that to make our lives easier. So now we swap it back. So we unlet 3 theta be equal to a. We let a be back equal to 3 theta. What do we get?
Cos 320.
No. You know the way we replaced 3 theta with a?
Yeah.
We now unreplace it. And so a goes back to being 3 theta because it was never actually a. That was just something we did to make our lives easier.
So then would you have to make just theta by itself and divide the other side by 3?
Yes, divide everything by 3. What do you get? And you can leave your answers as fractions.
Okay, just 40 over 3 and 320 over 3.
Yes, and so that way we get all of them in one go and we get 320 over 3 instead of my wrong answer, which was 1,000 and something over 3. So literally just the difficult bit, the thing in there, let that be equal to a, solve it as normal, and then at the very end replace it back to what it originally was and do the final bit of solving. And that gets around having to draw graphs, having to follow business, anything at all. Any questions there?
No.
Okay. And there's a little extra thing that I'm just holding back on until we do a bit more practice. Let us do same idea, question B. It's a bit trickier, but I think you'll be okay for it. Try question B.
Do you have to change them to tan?
You're right. Let me see. Yeah, it's gonna be tan. Why must they make our lives difficult? I just want to stick with something simple to begin with, just so we're doing one thing at a time. Let us do question B for this one.
Let 3 theta equal a, and then cos of a equals -1, and then a equals cos to the -1 minus 1, which is 180, and then do 360 minus 180, so we get 180. And then we change back, so 3 theta equals 180, and then theta equals 180 divided by 3, which is 60.
Great. And so that one actually just had one repeated solution. Good. Let me think. Yes. I'll now introduce the next little thing. You know the way we didn't have theta, we had 3 theta.
Yeah.
So 0 is between theta and 360. What is 3 theta between? How do you go from theta to 3 theta?
Times by 3.
Do it. What do you get there?
1080.
Okay. And 0 times 3?
Just 0.
And so we can leave it as 3 theta. That's fine. Or we said let 3 theta be equal to a. For this part, we can call it a. This part over here, it doesn't make it any easier. We said that a, we got our 2 solutions, or in this case a repeated solution. But actually, because of this stretch, where did it go? Because of this stretch, and stretch usually means stretched out. In maths it can be like a squash. We actually should get triple the number of solutions because we've squashed it down. And so a can be between 0 and 1080. We said it was 180 for both of those solutions. How can we get additional solutions?
Times by 3.
That's crazy talk. Cos graph, how often does it repeat?
Every 180.
That's tan graph.
360.
Bingo. And so how can we use that to get additional solutions?
Add 360.
Yep.
To 180.
Yep.
Or 60.
To the theta one would be wrong. It would have to be to the a one.
Yes. 540.
Yeah. So we said a was 180. It's also 540. Any other?
900.
900. Will there be another before 1080, or will that be outside of the range?
Outside the range.
That's it. So it'll go on forever. And so we now do this step of letting, like unletting or replacing it. So 3 theta is equal to those 3. And so how do you get theta?
Divide all of them by 3.
Yes. And so divide them all by 3. What do you get? And I know the first one is 60. You told me that one.
540 is 180, and then 300.
And 300. A beauty. Let me see. Question B. I don't have the answer, but I'm sure it's correct. And I could check with my calculator if I really wanted to. So cos of 3 times 60, and I should get -1. I do get -1. 3 times, so if you put in something like 540, that does work. Oh, why did they give me, this is special with this repeated one. So 180 also works, and 300 does as well. Let's try 181, and that's wrong. Yeah, so we can check our answer that way. Let us see. So the only extra step there was we have to, they give us a range of theta, and we just have to change that into what it is in the question. In this case, it was 3 theta. And so there are just additional answers because it gets squashed down. So let us try question D. Let you try.
So first we have to get rid of the cos. We'll do cos A equals a half. So let 2 theta equal A. And then A equals cos to the -1 of a half, which is 60. So A equals 60, and then we have to change it back.
Let's do that at the very end.
So would we find out the other numbers?
Yep.
So then we do 360 minus 60. And then, so 2 theta equals 6.
Nope. We now have to do this bit.
Oh, so times by 2, 360 by 2 is 720. So then would we do add 360 to 300?
Yep.
So we get 660 as the other one. And so those three, 60, 300, and 660.
2 theta is a squash of a half. We should have double the solutions. We started with 2. We're up to 3. You did 300.
How did we get the other one?
You did 300 plus 360, was it?
Yeah.
And so that was 660.
660. Yeah.
It works for all solutions. It will always work. So you can always do plus or minus 360 to any solution. But then it would be outside the range for this one?
Yeah.
Any solution.
What do you mean?
Was there any solution that you have not yet done plus or minus 360 to?
The last one, 660.
And so that would go outside the range and back to 300?
Yeah.
If only there was one other solution. Such as the very, very first one.
60.
Bingo.
Oh, add 360 to 60.
That's it.
So that's 420.
So A equals, sorry about these jackanapes. A equals 60, 300. What was that one? 420?
Yeah.
And 660. Is that full marks?
No. Now we change it back.
Yep.
So those are 2 theta. So then to get theta, did we divide all of those by 2?
Yeah.
Okay, so then theta equals 30, 150, 210, and 330.
That's it. And we could always check. So we said cos of 2 times 330, which would give us 660, is supposed to give us a half, and it does. There we go. And so, yeah, don't forget that the very last thing you do is to change it back to the theta, and that you find all of the solutions. So there were triple the solutions for this one. There were double the solutions for this one. Any questions with that?
No.
Okay. Let's get weird. Let's see. This one exam question. They're all cos for some reason. All right. Let us do. I want to do tricky one. Question 5a. Let's try that one.
3x, isn't that just like the same as like saying 3 theta?
Yep.
So if we let 3x equal a, then we have cos a equals minus a half, so then a equals cos to the minus 1 of minus a half. So a equals 120, and then we do 360 minus 120, and we get 240.
Okay.
And then then do we times 360 by 3 to find the range of how much?
Yep.
So 1,080. So then 240 plus 360 equals 600.
Mm-hmm.
And then add 360 to that, and we get 960. And how many is that? Don't we need more answers?
Sure do. What mistake did you make last time when you didn't have enough answers? How did you?
First one,
First
120.
One. Yep.
120 plus 360 is 480. And then do plus 360 to that.
Sure do.
Okay. 840.
840. And if you do 360 to that, will it be less or more than 1080?
More.
Yep. Okay, what's next?
So those are for 3x.
Mm-hmm.
So then to find x, we divide all of those numbers by 3.
Yes.
So 120 divided by 3 is 40.
Okay.
3 is 80. 160. 600 divided by 3 is 200. And then 40 divided by 3 is 280. And 960 divided by 3 is 320.
320. Which one was this? 5, 40, 80, 160, 200, 280, and 320. Boom. Any questions there?
No.
Okay, 6 marker. I'm happy. I'm glad I picked the tricky one. Let me now go back to the, in theory, easier one. In practice, who knows? Not that one, not that one. is it? This one.
So x plus 60. That does it shift the graph left?
Correct. Shifts the graph left 60 degrees.
So do we do the thing where we change it to left?
Sure do.
Okay, so sin A equals 0.3, so A equals sin to the minus 1 of 0.3, which is, how many decimal places should I do it to?
Let's do 3 sig fig.
17.5.
Okay.
So then for sin, do we do 180 minus that?
Yep.
180 minus 17.5 is 162.5. And then do we add 180 to that? Or does it go out?
What is the range?
300?
So we have, instead of x, we have x plus 60. How do you go from x to x plus 60?
Add 60.
Yep. What is the new range?
420.
And lower bound?
60.
Yes. So between 60 and 420. Okay.
But I thought it shifted left.
It did. It'll all come out in the wash. Basically, at the very end, to undo all this stuff, you'll have to do minus 60 to both sides.
Okay, so if we add 180 to 162, we get 342.5.
Maybe you do. Are you thinking of tan?
I shouldn't add 180.
You should not. The sine graph doesn't repeat every 180. How often does
360.
Every 360. Just a circle spinning around. That's all it is.
So we add 360. Then we get 702.5.
We never added 360 to the upper bound. So
780.
We never added 360 to the upper bound. So our bounds are between 60 and 420.
Yeah.
Do we have all of our solutions?
No.
So get all of the solutions.
But how?
How did you do it for the first 30 minutes when we had only 2 solutions and we needed more?
Add 360.
To what?
162.5.
Correct. And for some reason you always insist on adding it to the second answer first, but I'm fine with this so long as you get the right answer.
522.5.
Okay, 522.5. Is that it?
17.5 plus 360 is 377.5.
Yes. 377.5. What is next?
change it back
Mm-hmm.
to x plus 60.
Yeah.
So then do we minus 60 from all of the answers
Yeah.
to get to 17.5 minus 60 is minus 42.5. And then 102.5. 317.5.
Mm-hmm.
462.5.
0.5. And so I think the thing that you noticed in there, your reluctance, was that the boundaries, that we wouldn't have done this before because the boundaries, this, like you said, it's just a shift. And so which of these answers are valid, which are not valid?
Just the middle two.
Yes. And so you can, the reason why I get rid of them at the end, so you could have gotten rid of them, let's say, one step before the end. The reason why I leave them there is because, let's say this one, 17.5, that is outside of the range. It's too small because it now starts from 60. But by adding 360 to 17.5, you ended up with one of our solutions. And so you use things that are outside the range to get solutions that are inside the range. And so in general, just keep everything until the very end and then edit out what you don't need. So you don't have to think about it as you're going. So any questions about any of that?
No.
What else was I going to say? Yes, we don't have double the solutions because it wasn't a stretch, it was just a translation. So it didn't get smaller, it just moved 60 to the left. I think that's what you were sensing. And so that's what that is there. These ones, you're going to be fine for those. This one, let's take a chance. Let's take a chance and go for exam question. That's almost, that's kind of identical. Let's skip straight to part C for this one. That's two identical. Hold on. That's a different thing. Oh, okay. Let's try 7A. Take a big chance. We'll try it. Okay, let's try A.
Before, when we had the is the 5 being there the same as it being before the theta part?
No.
So can we divide it first?
Yep.
If it's on that. So now we can do, so if we let theta plus 30 equal A,
Great.
then sine A equals 4 over 5. Then sine 2 minus 1, 4 over 5. So then A is equal to 53.1. Then do 180 minus that. which is 126.9. And then we add 360 to 53.1, which is 413.1.
Okay.
And then we add 360 to 126.9, we get 486.9.
Okay.
So then, well, we have to work out the range.
So the way you did this, you kind of don't. Go on, try to solve this. I think you'll be fine.
Then we have 4 answers there. So if we change it back to theta plus 30, then do we do theta equals and then minus 30 from all the answers?
Yep.
So 53.1 minus 30 is 23.1, and then 126.9 minus 30 is 96.9, then 413.1 is 383.1, and then 486.9 minus 30 is 456.9. And does it go from 30 to 390?
That's what A goes from. Theta goes from 0 to 360, and you just went all the way and did theta.
Oh, so only the first 3 answers. Actually, no, the first 2.
You're right. So 23.1, 96.9. 23.1, 96.9. Kiddo, that's so good. That was such a risk. We skipped a whole chunk there. So you divided by 5 at the start, and even better. The very first thing you did was you let theta plus 30 be equal to A, which instantly turned this into a question that you already knew how to answer, that you'd previously solved, and that's how you were able to go all the way right to the very end without having to do any of this stuff, which I never even, you discovered something here. So you were able to do the whole thing and then just do that. That is very good. This A method is very, very good. Any questions there?
No.
Okay. And so because of how good you were for that, you shall be punished by doing something even more challenging, as is tradition in maths teaching. That's a life lesson. Good work is not rewarded with less work, it's rewarded with more work. Let me see. Here it is. No, did I? I think I skipped past one of these. We skipped past it, didn't we? Yes. B. How do we do B?
So do we have to turn them both to tan, so then they're the same?
What did you just do so well? That will be your second thing you do. What's the very first thing you do?
Let 2 theta equal A.
Yeah.
So then 2 sine A equals cos A.
Yep.
And then does tan equal sine over cos?
Sure does.
So then divide both sides by cos, and then we get 2 tan A equals nothing. 1.
Yeah.
So then if sine A equals a half, no, tan A, sorry.
Yeah.
So then A equals tan to the minus 1 of a half, which is 26.6. And then if it's tan, it repeats it's every 180. So do we do 26.6 at 180?
Mm-hmm.
Which is 206.6.
Mm-hmm.
And we need to work out the range.
Mm-hmm.
If it's 2 theta, then we times 360 by 2, which is 720. So we add 180 to 206.6,
Mm-hmm.
which is 386.6. And then add 180 is 566.6. And if we add 180 again, it goes outside our range. So
Okay.
So, we have so 2 theta equals 26.6, 206.6, 366.6, and 560.
I think my writing is bad. 386.6 you said before.
Yeah.
And
Okay, and then
566.6 I believe.
so to get theta to be divided all of those by 2.
I hope so.
26.6 divided by 2 is 13.3, and then 206.6 divided by 2 is 103.3, and then 386.6 divided by 2 equals 193.3, and then 566.6 divided by 2 is 283.3.
And you're done. They asked you to solve for theta. You just gave them what theta is. Let's take a lookie. 13.3, 107. They just round these. 3 theta. What? Oh, is this part A? Oh, that's part A. Wait. Where's part B? Part B's over here. 13.3, 103, 193, 283. Yes, and they just left out. They just rounded it to 3 sig fig. Great. Let me see. Yes, let it be equal to A, and then it is the same as the previous type, and you recognized that you had to, if you have a mixture of sine and cos, you can divide through by cos to convert it into tan. And so instead of getting 2 solutions with sine and 2 solutions with cos, you got 4 solutions with tan, because instead of it repeating every 360, it repeats every 180. So you get double that way, and that makes life easier. And this one, the range had to be changed because it was not a shift, it was a stretch. Technically, I would have to change the range even if it was a shift, but you didn't have to. I'm impressed. Any questions about this type?
No.
Right, I'm throwing you in. Exam question, hardest one I can possibly find of this sine type. I'm going all the way to the end. Let's see. Let's see. Sure. Let me see this one. Oh, I should have given you that one at the beginning. Well, maybe not. I'm seeing a lack of the sine one. All right, this is what they've got. Okay, let's go with 4 sine x, 3 cos x. No way. I'm going with the bottom one. 6a.
So, first we let 2x equal a. So we have 5 sine a equals 3 cos a. And then I think we want to get tan again, so so divide both sides by cos a.
Mm-hmm.
And then we have 5 tan a equals 3.
Yep.
So then tan a equals 3 over 5, so a equals tan to minus 1, 3 over 5, which is 30
degrees.
31.0.
Great. I'm just going to write 31. Okay.
And then so tan, we add 180 to that, which is 211. And then add 180 to that, which is 391. And then add 180 again, which is 571. And if we add 180 again, then it goes outside the range. So
how do you know it's outside the range? What did it get?
360 times 2 is 720.
Okay, just making sure. Go on.
And then, so that's for 2x equals 31, 211, 391, 570. So just x would be those divided by 2. So 31 divided by 2 is 15.5, and then 211 divided
And
by 2.
hold the phone. 15.5. Let me just take a look. Okay, go and get all of those. What are they going to be?
105.5.
Okay.
195.5.
Okay.
And 285.5.
Okay. I predict that these, at least some of these, will be slightly wrong. My prediction might be wrong, and it's because technically what we should do is keep our working out to 5 sig fig if our final one, let's say our working out to 3 decimal places if our final one is to 1 decimal place. Let's see if I have led you astray. 15.5, 105.5, 195.5, don't listen to me. What do I know? Correct. And it was a tricky one because it was this 5 sine and 3 cos. That method, just keep using that method and you'll keep getting them right. And technically, always do it to 2 degrees of accuracy more in the working out. So 3 decimal places, or if they wanted it to 3 sig fig, do 5 sig fig. Any questions there?
Nope.
Let's punch it. What is this malarkey? Okay. Whew, what's this? How do we do this?
Please can you move it over a little bit?
Down, is it?
It's fine, yeah.
Okay.
Sorry. Okay, so do we let kx equal a?
I like that.
And then so we have tan a equals minus 1 over root 3, so a equals tan to the minus 1 of minus 1 over root 3. Which gives us minus 30, and then because it's tan, We don't need to find another value.
Right.
Just one.
Okay.
So now minus 30, and then we change it back to kx equals minus 30.
I think so. Kx equals minus 30. Ah.
X. So if like the k wasn't there, then x would equal 60.
But the k is there, and x is still 60.
So
But I think
k equals minus 30 over 60.
yeah, I believe so.
Minus 30. It's minus a half. K equals minus a half, maybe.
K equals minus a half. Find a possible value of k. K equals minus a half. State with justification whether this is the only such possible value of k.
Probably not, because we could have had other values if we added 180. Because the graph repeats itself.
Sounds good to me. Yeah, they didn't give a range.
Yeah.
K equals 2.5. Oh, they snaked us. What's this? K is greater than 0. We should have read it more carefully. So if k is greater than 0, how do we get a value for k? I want to see.
Add 180 to minus 30 to make it positive. So then we have 150. So kx equals 150. So k equals 150. K equals minus 30 divided by 150, which is minus a fifth.
50. Let's not look around on it. So minus 30, 150, 60. What did you do? Minus a fifth.
Yeah. I don't know why.
K is minus a half. So 60k is 150. What is 150 over 60?
2.5.
Yeah. What did you do to? How did you not get that one? What did you do? Did you do 60 over 150?
I still used the minus 30 instead of the 60. I did 150 and minus 30.
Aha. Yeah. So you just we should have just followed our thing. Have all our answers first. So minus 30, 150. You could do a third one if you wanted to, and then you could divide them all by 60.
Mm-hmm.
And so there's definitely going to be more things. Yep. Any questions there?
No.
I really want to do a weird one. How would you start this one? How are you going to give it to me? This one.
Let a equal 5x minus 20.
Equal 5x minus 20. What would be the range for this one?
So, is it stretching the x-axis by a fifth?
That's what it will effectively be, but that won't really help you for your range. Just simple.
Minus 20 to both of those. And then at the end plus 20 to the answers.
Bidmus, young lady. And it would not kill you to do these one at a time. We have x. We need to get to 5x minus 20 You said subtract first, multiply second. I said bidmas.
So times both of them by 5 first.
Yes. So that would
So
give you...
we get minus 450 and then 450. And then now minus 20 to both of those.
Yes.
So we get minus 470 and 430.
Very good. That is how you do the range. So you go from x to 5x to 5x minus 20. Don't forget bidmas. And every other part of that, let me see, tan. Every other part of that will be the same. I'll let you do that one on your own time. I just want to see this one. Any idea how you start this one? 9a.
Don't you have to like focus on one side first?
Don't you have to what, sorry?
Oh wait, no. We want to get rid of tan.
How do you get rid of tan? So this is the question as it's given to us. This is the answer that they're saying we need to aim for. Spot the difference. We need to get rid of tan. What do we want instead of it?
Cos.
So we want sine and cos. How do we convert tan into sine and cos?
Tan equals sine over cos.
Yes.
So do we just write sine over cos instead?
Yes.
So sine over cos 2x equals 4 sine 2x.
That doesn't make sense. Do your let thing first.
Let 2x equal a.
Mm-hmm.
And then tan a equals 4 sine a. And then sine over cos a equals 4 sine a.
Still doesn't make sense. It always has to be the sine of something, cos of something. So you can't say sine over cos a. It is sine a over cos a.
Oh.
I don't know if that was just because you're kind of speaking it and not writing it, but yeah, you can't have just sine or just cos. It's like that would be like just square root. It has to be of something.
Yeah.
And what would you do next?
Times by cos.
Brilliant. Yeah. What would that give you?
Sine a equals you just write it in brackets like 4 sine a and then brackets cos a.
Yeah.
Like times, like that.
Or no brackets, same thing. XY, sine a cos a means times.
Then we want to get it equal to 0. So if we do minus sine a, so 0 equals 3 sine a cos a.
Nope. Just 4 sine a cos a minus sine a. So that would be like 4xy minus x.
And then they factorized it.
And then you factorize it. And that will be for you to do. Part B starts with the word hence. If you flopped on part A, had no idea how to do it, how could you do part B without doing any of part A?
Make up an answer.
Make up an answer, I'll beat you. Tan 2x equals 4 sine 2x is the same as this bracket thing, as the same as this equation.
Yeah.
They want us to solve this. How could you use part A to do part B even if you knew nothing about part A.
Use the second part of A.
Correct. You would just solve this. What would be step 1 in solving? I'm going to leave it as A instead of 2x. What would be step 1 in solving part B?
To expand the bracket.
No, we worked very hard to factorize it.
Divide.
No, you will lose half your answers if you do that. It'd be like dividing by x. How did you... I know how to... I'll give you a harder question and you'll be able to solve it. Sine A plus 3 and 4 cos A minus 1 equals 0. How would you solve that?
By multiplying them together.
We worked very hard to factorize it. X plus 3 y minus 1 equals 0. Or let's just say, I'll keep it simple, x minus 1.
So sine A equals minus 3 and 4 cos A equals 1.
There you go. And then go all the way back up to the original one.
So 4 cos A equals 1.
Yep.
And sine A equals 0.
Yep, that's it. Or sine A equals 0. So it's just GCSE brackets. Very, very different, very, very difficult trig stuff, but essentially it's the same idea. Something times something gives you 0. Either the first number is 0 or the second number is 0. One more thing. Are you in quarantine?
Yep.
That means you ain't going anywhere. Let me just do one more thing. I hate keeping students. I know you are busy ladies with busy social lives, but I just want to...
Not anymore.
Yeah. How would you do 7b? How would you start this one?
Would you still make theta over 2 equal to A?
Yep.
So then tan squared A equals 16, and then tan equals plus or minus 4.
There you go. That's all I was driving at. Yeah, you would square root both sides, plus or minus 4, and then you would solve from there. Great. So this method of let the difficult part be equal to A, do everything you need to do, and then swap it back again has been astoundingly successful. I think I stole that from some book, but who knows? I definitely didn't come up with that one myself. So harder trig equations, what do you give yourself there?
Tick.
Yay, brilliant. So no one's good at trig. Welcome to the club. It's very difficult. Probably this and exponentials is the hardest. Possibly applied mechanics, but that involves exponentials and trig. And we didn't get to identities. If you like, we can do that next time or something else. Do you have any preference?
We'll probably continue this.
Okay. And if you want to do something else, you can let me know.
Yeah, sure.
Any questions for me in general?
No.
Well done, kiddo. You did great. That was tricky stuff, and so I'm proud of you.
Thank you.
Well, have a good week. You stay safe, and I'll see you next
You
week.
too. Yeah. Bye.
Goodbye.